My dear students of computer science or internet technology, welcome back on Computer Guru VK Jayanti Computer and IT classes. This particular module we are discussing embedded systems and circuits. Friends, an embedded system is a combination of hardware and software designed to perform a specific dedicated function within a larger system. Unlike general purpose computers, embedded systems are task oriented, compact, reliable, and often work in real time. The definition of embedded system is a microcontroller or microprocessor based electronic system designed to monitor, control, or operate a device or process. The figure on left hand side shows the basic organization of an embedded system. Micro, if it is microcontroller, it has got a power supply system and sensor input and sensor output devices. And microcontroller has its own memory and software. So main components of an embedded circuit. First, we'll take up hardware components. This includes microcontroller, that is brain of the system, and example are Intel processors, ARM controllers. Memory, it has got ROM or flash program storage. It has got RAM, input devices and sensors. It may have temperature sensor, motion sensor, pressure sensor. Output devices are actuators, maybe in the form of motors, relays, displays, LEDs. And then in communication interfaces, UART, SPI, I2C, CAN, and USB. Uh, Software components may be first embedded C or C double plus. It has got firmware, that is ROM, device drivers, real-time operating system, application software. Examples of RTOS are FreeRTOS or VxWorks. Central processing unit of a processor or microcontroller. The central processing unit is main component of embedded system. It acts as the brain of the system and is programmed to perform specific tasks using programming languages. The CPU is an integrated chip in a computer that includes an arithmetic logic unit, a real-time clock, a stack pointer, a program counter, serial ports, internal interrupts and external interrupts. However, the CPU cannot function alone and requires other peripherals to be connected to it. A microprocessor also has the following component attached to it. So it has got a RAM or ROM, RAM and ROM both. Uh, it is a general purpose processor. It has got a serial port and number of timers and input output ports. Controller is a complete single chip integrated computer. It has a built-in RAM, ROM, timers, input output ports, serial communication ports, analog to digital converters, counters, and digital to analog converters, which make them ready to use single chip integrated computers. A microcomputer can be easily interfaced with sensors and other interfacing devices due to built-in input-output ports. The following are the famous families of microcontrollers. Microcontroller can be easily interfaced with analog digital sensors to control and monitor data for data acquisition. Types of embedded system can be viewed based on function. One, standalone embedded system, example microwave, oven, calculator. Second, real-time embedded systems, maybe hard real-time, airbag control, soft real-time, multimedia. The third category may be network embedded system, example routers, smart meters. Fourth, mobile embedded system, examples smartphones, wearables. Android is one of them. Friends, now real-time embedded systems. These respond within a specified time limit. Hard real-time system, missing a deadline can cause failure. Examples, aircraft control systems, airbag systems, safety systems, on-call, pacemakers. Soft real-time systems, minor delays are acceptable. Examples, multimedia systems, online video streaming, third printing. Friends, third category network embedded systems. They are connected through a wired or wireless network for communication and control. Examples, smart meters, routers, home automation systems, Internet of Things devices. D. Mobile embedded systems. Portable embedded devices powered by batteries. Examples, smartphones, wearables, GPS device, digital camera. Now classification based on complexity. A. Small scale embedded systems use 8-bit or 16-bit microcontrollers. They have limited memory. They use simple programming. Examples are TV remote, digital clock, and toys. Medium scale embedded system use 16-bit or 32-bit controllers, more memory and peripherals, may use RTOS real-time operating systems. Examples, printers, industrial controller, and automation equipment. Now friends, sophisticated large-scale embedded systems. They have high-performance processors, complex software and operating system, may include networking and artificial intelligence. Examples: automotive control units, medical imaging systems, robotics, and avionics systems. This diagram completely defines and describes microcontroller or a microprocessor as a part of microcontroller. So this is the complete diagram of a microcontroller. Microcontroller has microprocessor, inbuilt RAM and ROM, and input ports. They have got input ports, they have got output ports, and they communicate with external circuits in and out. They are connected for input signal, physical devices, and output signal, physical devices. They have got three bus: address bus, data bus, and control bus. Friends, at last we are dictating requirement for embedded systems. Embedded systems are specialized computing systems designed to perform a specific task efficiently by integrating hardware and software components. Below are the key requirements and considerations for developing embedded systems. First is hardware requirement. Embedded systems rely on hardware components such as microcontrollers or microprocessors, sensors, actuators, memory, input-output interfaces, and power supply. These components must be compact, cost-effective, and energy efficient to meet the system's specific functional and performance needs. Software and firmware. The software in embedded system is typically written in languages like embedded C, embedded C++, or embedded Python. Firmware, which is tightly integrated with the hardware, contains optimized instructions for real-time processing and system control. The software must ensure reliability, low latency, and decision and efficient resource utilization. Real-time operation. Many embedded systems are real-time systems, meaning that they process input and produces output within the strict time constraint. This is critical for applications like medical devices, automatic system, and industrial automation. Low power consumption. Embedded systems are often designed for low power usage to extend battery life in portable devices or reduce energy cost in industrial applications. Cost efficiency. The design and component of embedded system must be cost effective to ensure affordability, especially for mass production.